Say, hello class.
Hello, class.
So,
So today we're gonna learn something very important today. Something very special today. And it's very nice too. We're gonna learn about friendship.
we're going to learn about projectile motion, but friendship's very nice too. Okay, so we're going to do an example of projectile motion. So let's read the problem and then we'll work it out together. A diver springs upward from a board that is 3 meters above the water. At the instant she contacts the water, her speed is 9 meters per second and her body makes an angle of 75 degrees with respect to the horizontal surface of the water. Determine her initial velocity, magnitude, and direction. Okay, so here's the diving board. So the first thing you want to do with these problems is definitely draw a picture. Draw a picture is key. So here's the diving board right here.
Yep.
And it's 3 meters above this water. The water's yellow. Why is the water yellow?
Because
Is someone peeing it? Oh, that's gross, huh? I don't know why it's yellow. So this is the path that the diver's going to take. The diver's going to jump up. The diver's going to go up for a little bit and then fall back down into the water. So we know that the diver's final velocity is 9 meters per second with respect at 75 degrees with respect to the horizontal. And so here's a picture of what's going on. Okay, so whenever we work out these projectile motion problems, we're going to write out our givens. We have the x and the y part. For the x part, they all have, so change in x, acceleration in the x direction, vi and vf in the x direction, and then time. Same for the y.
No.
What?
X off. It looks like we do.
Yeah. Yes.
F, X,
Yes.
V.
That's right. Now, the only thing that's going to be the same for both sides is our change in time. It's going to be the same for both sides of the equation. Okay. So let's start filling it in. So acceleration in the x direction is always 0, and acceleration in the y direction is always negative 9.8 if you're using Quest, or you could use negative 10 in class if you like. It's I always say always for things flying through the air. Now remember, our change in y and our change in x is our displacement, not our distance. So we're not looking at the distance.
I sit right here, Mama?
Okay, you can sit there. It's not the distance that the diver travels up and then down. It's the displacement. So since the diver starts here, oh, thank you. It goes down. That's the displacement of the diver. We also know that our final velocity in the x direction will be 9 meters per second cosine 75, and our y velocity will be 9 meters per second sine 75.
Yep.
Now, since we know our final velocity here, we could get numbers for that. We'll plug into our calculator and get numbers. We know that the initial velocity and the final velocity in the x direction is the same because it doesn't speed up or slow down in the horizontal in the x direction. Think of the Energizer Bunny. So we want to find what is our initial y velocity here. So we know our initial x velocity. We want to find our initial y velocity. So let's go to the y direction here. We have 3 knowns, a want, and change in time will happen to be a don't care. So we use the equation that does not have change in time. It's our last equation. Oh, that should be a change in y, not dy. Excuse me. We plug in our givens, chug out an answer, and that's our velocity in the y direction, initial velocity in the y direction.
How did you know that, Mama?
Because we put it into the calculator.
Oh.
Now, when you take the square root, you're going to get a plus or minus, and you have to figure out if it's a positive y velocity in the y direction because it's going up, or a negative velocity in the y direction because it's going down. But in this case, it's positive because the diver's jumping up. And then we do Pythagorean, we do Pythagorean theorem to find all our initial velocity total. And there we go. We'll work out some more problems in class.